Let's start example 3.2. We have to find center of mass of a solid cone. So you can see, first we have to consider a volume in which charges are distributed. We have to take a small charge in both sides. Okay, when we're taking a charge on both sides, you can see there is also volume dl, and the electric field of both charges will cancel out, and it is at the origin with radius r. And when we talk about the density of these charges, so this is the charge per unit length. Okay, and the thickness of these area, these is negligible. Okay, so this is according using this example, we have to find these cone and center of mass of these cone, which is very easy. So you can see you have a cone which is along z-axis with radius r, which is the largest radius of the cone, and there is also another radius which is the small radius of cone, which is equals to this rz over h. You can find out by yourself. You can see this is the height of this cone, and when we talk about the small radius, it's obvious there is some divide in height. Okay, so there is a symmetry when we consider the point x of that integral, it cancelled by that point. There is three coordinates x, y, z, and when we talk about x, so there is a cancellation of x. So x is cancelled, and we have only minus x, y, z. X is decreased, it means it lost. Okay, so x is 0. So now we have to consider the formula of center of mass, which we studied in the topic already. You can see, so when we talk about the density, mass per unit volume of these cone, now you have to put the value of these dm, which is equals to density into volume. After putting, you can see this density is constant. It's obvious this should be not equals to 0. Okay, and dv is equals and to these terms, and the volume is discussed obvious in a long 3 coordinate system. So after evaluating, after applying, integrating separately in the individual unit vector, you can see this is the x unit vector value, this is the y unit vector, and this is z unit vector component. Okay, and you can see the cone is only along z, so these two terms will cancel. Okay, there is no need to write anymore. So z is similar. Now you have to integrate separately again. We can apply integration on dx and dy. So there is two integrals, so we have to differentiate in the form of second order term. Okay, you can see there is integration. Now we have to integrate individually, and after integrating, we will get for any given z the integration over, this is the double derivative of these terms, because there is a double notation, double integration. So after an integration, after integrating, you will get the value of area. Okay, then you have to find the volume, and after that you will get the center of mass of cone. So this is the radius, again we have to consider it. You can see, now we have to consider these area of circle, which is equals to pi r square, and these r is the small radius of the cone, and this is the large area radius of the cone. Okay, now you have to put the radius value, which is this, after putting and arranging square, and you can see. Now you have to again let equation 1, and equation 1 is this. Now you have to put, this is the value of double integration. Okay, double integration means that we have to integrate individually on dx and dy, and after that we gain these terms. Okay, so this value is actually equals to this value. So now you have to put this value in this formula, and z dz integration same. You can see after arranging z square, it's obvious it moves to the z term, and after taking product we will get z cube. Now you have to integrate on it. Z4 equals to 4, and you know that this height is equals to this z, which is the motion, which is the replacement of the cone in actual. Okay, so you can see z is equals to this h. Now you have to cancel the same terms. You will get these area of the cone. Okay, this is the area actually of the circle of the cone. Okay, now we have to consider again volume. So when we talk about the volume, this is along both in all three terms. Okay, so you can see now we have to uh, these two terms take separately, and these terms obvious separately. Now you have to put these same value again we calculated before. Okay, now z square will go under integration, and now you have to put these m equals to, which is equals to this density into volume in equation 2. Okay, so where is equation 2? Here. Okay, you have to put the value of m, and which is equals to this density into volume. So now these term we have to put these value in equation 2. So you can see after putting the value of m, you will get these density and these density will cancel, and we are remaining with this one over volume. So after putting the value of volume, we have proved already. After putting these value and arranging, these denominator term will move on numerator, and after cancelling the same terms, we are remaining with these 3 over 4 h. Okay, so what we have actually required and what we have find, the cone is this. So this is the third over fourth part of these cone. Okay, so center of mass is the third of the fourth part of the center of mass of the cone.